Hey guys, so this worksheet that we're working on today is over like beginning of the chapter 3, like sections 3.1, 3.2, and 3.3. So we're talking about units, conversions, scales, and rates, right? Just so some things to remember from the text that you should have read, right? So we have this idea of units, and that there's two different types of units, right? So we can have units of observation, which is where we're putting things into categories, right? Or units of measurement, where we're actually measuring things that's some type of quantity, right? Such as length, and so forth, right? So then also we have another definition where we have conversion. So it says a conversion is a ratio used to compare two different types, two different systems of measurement, right? So we can use ratios and proportions to solve conversions, right? I'm going to show you a second way how to do this, right? So if we look at problem number 1, we want to convert 149.6 kilometers into feet, right? I want to go from kilometers, and I want to convert this into feet eventually, right? But if you think about this a moment, right, if we look at my conversion facts, so I have two conversion facts given to me. I have how kilometers and miles are connected, and then I know how miles and feet are connected. So it can be difficult to go straight from kilometers to feet, right? So what we kind of writing out our game plan, what we want to do is take our kilometers, convert this into miles, and then convert this into feet, right? So that's kind of our game plan, and that can be helpful before you start doing a problem, no matter if you'd use proportions or I'm also going to do this problem using dimensional analysis. Right. Right. So to do this using proportions, right? So first way using proportions, you would do the following, right? We need to actually do two proportions. So I need one proportion to do this part, so going kilometers to miles. And then I'll need another proportion to do this part, miles to feet. Right. Alright, so remember, set up a proportion. We're comparing two fractions, right? Two ratios. So off to the side, you might write kilometers and miles, right? Just to help us keep track that miles are on the bottom, kilometers are on the top. On either the left or the right hand side of the equal sign, you're going to want to write your conversion fact. So I know that 1 kilometer is equal to 0.6214 miles. Right? Alright. See if I can get this here. So alright, so that's a better 6. Alright, so then what we're trying to do is convert 149.6 kilometers, right? So on this left hand side, I'm gonna wanna put the items for the conversion fact that we're trying to do, right? So I'm trying to convert this into so many miles, right? So we can say X miles, if you will, right? So this fact will go on the left hand side. So I can do 149.6 kilometers and then X miles. So now we need to solve for X, right? So you should be pros at solving proportions by now, right? So we need to cross multiply. So I would end up getting X equals 149.6 times 0.6214, right? So if you plug that in your calculator, so 149.6 times 0.6214, I get 92.96144, right? So, and you're going to want to keep all of this, right? Keep all this number so we don't have a large rounding error, right? Actually, this fact between 1 kilometer and 0.6214 miles, this is already approximated. This isn't an exact figure, right? But it's close enough for what we're working with. So if this is approximated, and then we approximate this, and then I use that again to solve for how many feet that I have, you can imagine this is going to create a huge rounding error, right? So you don't want to keep rounding, and keep getting different answers, right? And just to be clear, the unit here, this was in miles, right? So basically what we know right now is we know that 149.6 kilometers equals 92.96144 miles, right? So now I want to take this 92.96 miles, I want to convert it into so many feet, right? That's what we're after in the very end. So now I need to do another proportion, right? So I set up another proportion. So we're going from miles to feet, right? And the connection that I know is that 1 mile is 5,280 feet. The 92 number is in miles, so that's going to go on the top, right? So 92.96144, and I'll use a different variable here. We'll use y, right? So y is going to be equal to 92.96144 times 5,280, right? So if we plug that in your calculator, you should get y equals 490,836.4032, right? So this is your final answer, right? This is in feet, right? Good. So that's one way to do it. One thing you'll notice is it's not nearly as convenient to use proportions. You can certainly do it this way, but we're converting, going from, since we're going from kilometers to miles to feet, I have to use two proportions, right? Essentially, however many arrows here that you need to use in your game plan, that's how many proportions you're going to have to set up, right? Because that indicates a conversion, and every time you convert from one unit to another unit, you're going to have to do another proportion if this is the only method that you stick with. So let me show you an alternative method. So let me erase all this. All right, almost done. All right, so one thing that I want to make sure that you're doing is watching the videos. So if you will email me what I'm about to tell you, then I will give you some extra credit points. Excuse me. So today my son had a travel baseball game, and they played the Gahanna Lions. So if you email me the name of the team that we played, the Gahanna Lions, I will give you some extra credit points. And that's just to give you some credit for putting in the work and watching these videos. Excuse me. Man. All right, so the second way to do number one is we can use what's called dimensional analysis. Right? So one thing that you want to know with dimensional analysis is when we do dimensional analysis, we're going to set up some unit fractions, right? So I'll do this off to the left here. Right, and we're going to use these unit fractions for the conversion. So, for example, if I look at this first conversion, 1 kilometer to 0.6214 miles, then I can convert this using unit fractions. So what you do is you put one side of the equation, right, then the fact over top the other. So 1 kilometer over 0.6214 miles. Right? So we could also have the flip of this, right? The reciprocal. So you could do 0.6214 miles. Let me give some more room. Miles over 1 kilometer, right? And what we know is the 1 kilometer is equal to 0.6214 miles, right? Well, I told you that this figure is rounded. In between anytime you go between the US and the metric, right? Most of those are rounded, right? They don't come out exact. But this is close enough, right? So this might be approximately equal, but it's close enough for our purposes that we're just going to say they're equal, right? As it's given. So if you have 1 kilometer equal to 0.6214 miles, and you take one divided by the other, right? What happens, right? So for example, I know that 5 equals 4 plus 1, right? So what happens if I take 5 divided by 4 plus 1? Well, we get 1, right? Because these two things are equal to each other, right? So that would be the same thing that happens here, right? This is going to be equal to 1. This is going to be equal to 1. So if I look at the other fact that we're given, 1 mile equals 5,280 feet. So I can make this unit fraction, or I can make 5,280 feet over 1 mile. These are equal. These are also equal to 1, right? And these are equal also, right? For the same reason, these are equal to 1. So we're going to use these fractions to convert, right? And something else to remember is the multiplication property of 1. So multiplication property of 1, right? So this is just recalling, or it could be called the multiplicative identity, right? So you may have used one of those two words before, but this is just talking about the scenario where if I have any number a times 1, I get just a back, right? So in other words, anything times 1 is itself, right? Just talking about that property. So if I start out with 149.6 kilometers, right? So I can still come up here and do a game plan, right, as we had before. So let me just write that down as a reminder. So remember, we want to go from kilometers into miles and then into feet, right? Because I don't have a direct connection to go from kilometers to feet, right? That's not what was given. So if we go from kilometers to miles, and then we can use this conversion to go from miles to feet, then we can get to the end result. So I'm going to use this game plan. Right? So then what I want to multiply next is I'm going to want multiply by one of these unit fractions over here, right? But I'm going to want kilometers on the bottom, right? Because one thing that you should have learned is that units work a lot like when we multiply numbers together or divide by numbers together in that sense, right? So for example, if I take x divided by x, I get just 1, right? If I take 6 divided by 6, I get just 1. So keeping that same tradition, if I take kilometers divided by kilometers, then these cancel out, right? Just like the 6's would, or the x's, right? We say they cancel each other out, right? So if we write it in this fashion, then my kilometers will cross out, right? So now I don't have any units how it's written, right? But I do want some units here, right? I want miles. I want to convert into miles. So since I don't have any units left, if I write miles on the top, now everything is in miles. So I need to fill in some numerical values here to make this work. So if I look over here at my unit fractions, we want the one that has miles on the top and kilometers on the bottom, and that's this guy, right? So I can fill that in, 0.6214 and 1 kilometer, right? We know that they're equal, right? So now I want to multiply by another unit fraction, but for a similar reason, I want miles here and feet here, right? Because if I have miles on the bottom here, this will cancel with this miles on top, right? So you'd have miles over top of miles, and then what units left is feet, which is what we're after. So I need to fill in a one of my unit fractions here that has feet at the top. So there's 5,280 feet in 1 mile, right? So now with doing this, I don't have to do multiple proportions. I just multiply straight across, right? And as you do this more and more, this is probably the fastest way to do it, right? And one of the most preferred, especially if you end up taking like a chemistry or physics class. The sciences use dimensional analysis a lot to convert, right? It makes things a lot easier. Or if you're taking like dosage calculations in our nursing program and so forth, this could be very useful to you, right? So if I just multiply straight across, right, what I would get is 149.6 times 0.6214 times 5,280 feet all over, and there would just be 1 at the bottom, right? Because we'd have 1 times 1 times 1. Right, so if we do this, so 149.6 times 0.6214, right? And then times 5,280, you still get the same value, right? Which was 490,836.4032, and this is in feet, right? So 149.6 kilometers is 490,836.4032 feet, right? So now with number 2, it asks us to write down the equation for this proportional relationship using kilometers and feet, right? So let's go over here with, let's say, so let's K equal kilometers, right? And let's let F equal the number of feet, right? So, excuse me, this should be kilometers equal the number of kilometers. So let K equal the number of kilometers, right? All right. So if we do this, what would we get going from kilometers to feet, right? So we could do K over F, right? Kilometers to feet equals, and then if we use the information from above, we know that there was 149.6 kilometers. Right? And then if we go ahead and just round this to the nearest tenth, right? So 1 decimal place, we would have 490,836.4 feet. Right? So this could be a setup, right, of a proportion. So if I want to turn this into an equation, I could just solve for K, or I could solve for F, right? So let's go ahead and solve for K, right? Because that's what we were trying to do. So above we were going from kilometers to feet. So let's go ahead and solve for F, right? So if I use this to solve for F, right, we just need to cross multiply. So I would have 490,836 point 490,836.4 times K equals 149.6 times f, right? So we cross multiply. So make a big X, cross multiply, right? And that's what we get. So remember, with cross multiplication, if we have A over B equals C over D, right, then AD equals BC, right? We just cross multiply, right? And this is K, right? And actually looking ahead, if we look at number 3, we want to convert kilometers into feet. So in other words, I want to be able to plug in kilometers to get feet. So this should be my input, and this is my output, right? So thinking ahead, I want to solve this for f, right? As I said below. So if I solve for f, I'd want to divide both sides by 149.6. So this becomes 1, right? So what I'm left with is f equals this left-hand side, 490,836 K, all divided by 149.6. Right? And if you want, you could take K and leave it out here, right? So we have f equals some constant times K. Right? So now if we look at number 3, I want to convert 149.6 million kilometers to million feet, right? So 149.6 million kilometers is the same thing as 149.6 times 10 to the 6th kilometers, right? So 1 million is 6 zeros, right? So that's 10 to the 6th power. So when I plug this in, I could write f equals, so 490,836 all over 149.6, and I can multiply this times what we were given, so 149.6 times 10 to the 6th kilometers, right? So then when I multiply this out, what happens? Well, the 149.6, this cancels out, right? Because 149.6 divided by 149.6 is going to give me 1. So I'm left with f equals 490,836 times 10 to the 6th, and this would be feet, right? F it represents the number of feet, so this is in feet. But remember, times 10 to the 6th, this is just million, right? Equal to 1 million. So I could say this is 490,836 million feet. Right? And that's what we were asked to do, right? Convert 149.6 million kilometers to million feet. Right? So now we're in terms of million feet. All right, so then on the next page we have 2 more definitions listed above, letting us know that we have 2 types of scales that we can encounter, right? So the first thing is a measurement scale. So this is some system where we have ordered marks like a ruler, right? And these can be ratio scales or interval scales, right? Depending on whether the units are ratio units or interval units, right? So that's what number 1 is saying. Number 2 is talking about a model scale, which is a ratio used to determine the size relationship between a model and that which it represents, right? So an example of a model scale is like number 4, right? So number 4, we're dealing with the planets, right? So if we want to take our actual solar system and keep the planets at the same size and the same distances away from each other, we obviously can't make a model that's a 1-to-1 scale of the universe, right? Because that would be the universe. But what we could do is scale this down and be able to put this in a smaller space, but everything is still relative, right? We still keep that same proportion of distance the same, right? So like if you went to a science museum, right, and they wanted to, I don't know, maybe paint along the hallway um, how big the planets were and also show the size away that the planets are away from each other. You could use mathematics, use proportions to be able to do that, right? So here we're given, if you notice, we're given a table where we list 3 planets, and we're told how many million kilometers they are away from the sun. And then here we have distance in the model. So we already have filled in that we want the Earth to be 1 unit away from the sun. Right, so we need to be able to figure this out. So we could use proportion to do this also. Right? So if we focus on Mercury, right, trying to fill in this blank here, this top blank, we could go, let's say we could go Mercury's distance to the Earth, right? So Mercury is 57.9 million kilometers from the sun, and the Earth is 149.6. Right? Make that better. Right? And then Mercury, we're trying to fill in this blank, right? So this is X, right? If this is X. And then we want this to be 1, right? We're scaling the Earth quantity to 1. So if I do some cross multiplication here, you end up getting that 57.9 equals 149.6x, right? So x would equal 57.9 divided by 149.6. So this comes out to be about 0.387. So about 0.387. Right? So then to do Venus, right, it's best to use this bottom row every time, right? The reason being that those are given values to us, right, where this was rounded, right? So remember, I've talked about this a lot. We want to avoid using answers that were rounded to find another solution, right? So then we get this big rounding error. So what I would do is compare Venus to the Earth. Right, so Venus, we have 108.2 over the 149.6. And then the distance in the model for the Earth is 1, and we'll let this be z, right? Some variable. That's what we're trying to figure out. So if we cross multiply, you'll get 149.6z equals 108.2. So if I divide both sides by the 149.6, I'm left with z equals 108.2 divided by 149.6. Right, so with this, I get about 0.723, right, if we round this. Seven, 2, 3. Right, so here this will be 0.723. Right, and notice here I don't have any units in this, right? And in the next one, that's what we're going to look at. The reason why, right? So the reason why we don't have any units that is unitless is because my units cancel out, right? So when I have, for example, looking at this proportion, if we look at the left-hand side, I have 57.9 times 10 to the 6th kilometers over 149.6 times 10 to the 6 kilometers, right? That's the unit that we're in, 10 to the 6 kilometers. so a million kilometers. When I divide by these things cancel each other out, right? The 10 to the 6 divided by 10 to the 6 is just 1, and the units cancel. So I'm left with just this, without any units. So this distance in the model, this is unitless, right? And this can be very helpful because I can let this be 1 mile, 1 inch, 1 feet, 1 centimeter, right? Whatever you want it to be. And as long as you're using the same unit for all three things, it will keep the same ratio, right? That's the key, is that all of these must have the same units when you build your model, right? So then we're provided with another definition. So a rate is a special type of ratio, right? That's what we're given. So a rate is where we're comparing two different things, but our two different things are two different types of units, right? So we're given some examples like meters per second, miles per gallon, right? And these are referred to as compound units. Also, another thing that was mentioned here in the text, we have also what's called a unit rate. So a unit rate, if you remember, is when you have when you scale the second quantity to 1, right? So for example, 50 miles per hour is a unit rate because this means 50 miles in 1 hour, so over 1 hour, right? So the second quantity is scaled to 1, where we could do 100 miles in 2 hours, right, which would be equal to 50 miles per hour, right? So this would be a rate, how it's written, and then to convert this into a unit rate, you just have to scale the second quantity to 1, right? So this would be a unit rate, right? So then going on to page 39, looking at number 6. So we're given that says in 2011, nearly 14 million monthly prescriptions were written for American adults 20 to 39 for ADHD, right? So this is some monthly magazine, right? It says if there were 82,364,000 adults aged 20 to 39, compute the following. So number 6, we want to compute the rate of prescriptions per 100 adults aged 20 to 39. Right? Right, so to do this, to find the rate of prescriptions per 100 adults, I would compare, let's see. So you'd want to compare the number of prescriptions, or not prescriptions, prescriptions. Well, I think that's written wrong, right? I think there's a typo here. This should be subscriptions, right? Oh no, that's right. It says they were written. So excuse me, I read this wrong. This is not talking about subscriptions to a magazine. This is calling prescriptions for some medicine, right, for ADHD, right? So this is prescriptions compared to total adults, right? So age 20 to 39 adults. So what we have, so there were 14 million, so this would be 14 times 10 to the 6th, right? Remember, 1 million has 6 zeros, right? So 10 to the 6th. 1,000, right, has 3 zeros, so that's 10 to the 3rd, right? So we had a 14.10 to the 6th prescriptions, and then there are 82,364 times 10 to the 3rd, right? Because that's 1,000 adults. So what I want to do is I want to have 100 adults on the bottom, right? And we want to find x here. So to find x, I would take 100 times 14 times 10 to the 6th and divide this by 82,364 times 10 to the 3rd, right? So one thing you want to remember though is, 10 to the 3rd times 10 to the 3rd is equal to 10 to the 6th, right, by exponent rules. So I can erase 10 to the 6th and write in 10 to the 3rd times 10 to the 3rd here, right? So in doing so, this makes my calculation easier, right? To get rid of those 10 to the 10 to the 3rd down the bottom, right? If you don't like that, you could just type this on the calculator and it would be able to handle it for you also, right? Just depending on your preference. So when you type this in and simplify it, right? So if we take 100 times 14 times 10 to the 3rd, and then divide this by 82,364. This gives me 16.997, so forth, right? So if we want to round this like to the nearest 10th or 100th, this would end up giving us about 17, right? So in other words, out of every 100 adults, 17 of them are having some prescription written for ADHD, right? So 17 out of 100 adults are getting a prescription for ADHD. So number 7 is where we're writing the rate. So to write this out, right, we would have 17 prescriptions per 100 adults ages 20 to 39. Right? So if you were asked this like on the exam, you'd want to be able to write it out in something to this effect, right? Writing this out in words, what the rate is. And it's so important to use the units, right? We want to be as specific as possible. So you wouldn't want to say just adults, right? We're talking about adults aged 20 to 39, a specific group of adults. So the number 8, it says the rate of prescriptions per 100,000 adults 20 to 39, right? So if we have this 17 over 100, right, and I want to put this per 100,000 adults, right, then I need to solve for A, right? So I want to convert this, I want to scale the second quantity to 100,000 now. So in doing so, we would have A equals 17 times 100,000 times 100. So 17 times 100,000 times 100. Or excuse me, should be divided by 100. Right? So this should be divided by. Right? Then when we get, this should be come out to be 17,000. Right? So there's 17,000 prescriptions per 100,000 adults aged 20 to 39. Right? So number 9 says, which do you think is best? So comparing 7 and 8, which one do we think is best? Well, what I think is best is number 7. So I personally, I like the ratio 17 to 100, right? And that's because 17 out of 100 is 17%, right? So we're easier to see the 17% come out, right? And it's easier to talk about, easier to share. And we can say, on average, 17% of U.S. adults in this age group 20 to 39 have a prescription for ADHD, right? So then the next is the definition, right? Another definition. But actually, before I go on to that, for number 8, you could have done this a little differently to be more accurate. So, oops. Hang on. So one thing that you could have done. Let me make some room. Is you could have simply just used more decimals, right? So up here we got a bunch of decimals. So you may have used some more decimals like 16.9977, for example, and then put this over 100 and then converted, and you end up getting A is equal to 16,997.7. Right, so you could fill that number in instead of 17,000. So another thing that we could talk about in number 9, if you would have converted it this way, is that this guy is more accurate, right? But it's still hard to talk about, right? Hard to make meaning out of this. So what we end up scaling our second quantity to can make a difference for the meaning, like what we're trying to use this for, right? So in the last definition, right, it's talking about concentration. So you want to remember from the text that the concentration of a solution is simply a ratio of the amount of one substance with the amount of another substance, right? So concentration is a ratio, right? So that means we have a fraction. And what we're comparing is the amount of substance 1 compared to the amount of substance 2, right? That's what a concentration is. So this, it says this may be a weight to volume ratio, but also could be weight to weight, right? And then the other thing we're given is dosage. So dosage is also a type and application of ratios. So this is where we're comparing the amount of medicine compared to the weight of the patient, right? So you might want to keep these handy, right? So I just turned those words into some equations for you. Might make a little more sense. So then at the top of this next page, we're given a chart of some common conversions, and I don't expect you to memorize these at all on the exam. If you need some common conversions, I'll certainly give those to you and built into the exam. Right? So we have those given here. And notice a lot of these use this symbol, right, which is approximately, right? So that's approximately symbol, and then some are exactly equal, right? But remember, when we're doing the conversions, we just treat them all as equal, but this is just pointing out that this amount, like for example, this amount here is rounded, right, when we convert grams into ounces. So this means approximately. So number 10, it says convert the density of water, which is 1 gram per milliliter, to pounds per gallon, right? So I want to go from 1 gallon to 1 milliliter, right? So that's the density of water. And I'm going to convert this into pounds per gallon. So I'm going to want to go from grams into so we want to see a connection that we have between, if there is a connection between grams and, into pounds, right? So I see grams into kilograms, and I see pounds to kilograms, right? So here and here I'm looking at these two facts. So it looks like what we're going to have to do is go from grams to kilograms and then take that into pounds, right? So let's set this up. So I'm going to have to multiply by two things at least, right? So I'm going to want grams here, so that way these cancel out. And then I'm going to want kilograms here, so now I'm in kilograms. And then when I multiply by this second parenthesis, I'm going to want I want pounds, right? So if I put kilograms at the top here and at the bottom here, those will cancel out, and then I'm left with just pounds. So I have that taken care of, the pounds part, right? So that's good to go. But now I'm going to have to make some more fractions. So I want to convert milliliters into gallons, right? So let's look and see what we have for milliliters and gallons. So I have a connection here, 1 liter to fluid ounces, so that doesn't do milliliters. So one that's not listed here is that there are 1,000 milliliters in 1 liter. Right, so this is something that you should know from the metric system. So we'll need this. So what we could do is go from grams into, or excuse me, milliliters into liters, right? So if I go from milliliters to liters, and then let's see if there's a connection between liters and gallons. So there is here, right, at the very bottom. So we could go from milliliters to liters and then into gallons. Right? Oops. So let me move this up here. There. Now I have some room to write. So to go from milliliters to liters, right, I'm going to want milliliters on the top, right? So that way that this milliliters on the bottom cancels out with the one on the top, right? We always want an opposite. So then if I want to go from milliliters to liters, I'm going to need liters here. And then lastly, I'm going to want liters to cancel. So I have one on the bottom already, so I need one on the top. And then on the bottom, I'm going to want gallons. Right? So then this liter will cancel with this liter. So what units do we have left? Well, we would have pounds over top of gallons, which is what we want, right? Pounds per gallon. So I'll write off to the side. So currently what we're in, the unit, is pounds per gallon. Right? So after doing this problem, you can really appreciate the idea of dimensional analysis, right, that we've talked about, and how much easier this would be than proportions. Because if we did proportions, how many proportions would you need to solve this? You would need to do 4 proportions, right, in order to do this. So it's much easier to do dimensional analysis, multiply everything. So now what we need to do is fill in these with numerical values, right? So I have it all set up in terms of the units canceling out, but now I need to actually fill in the values, the numerical values, to solve this. So our fact between kilograms and gallons, or grams, excuse me. So kilogram and gram. Let's see, do we have one listed? Oh, yes, excuse me, right here at top, right? So we know that 0.0 0.001 kilograms equals 1 gram, right? So I can fill that in. And then for pounds to kilograms, yeah, I drew an arrow beside those, right? So we know that 1 pound is equal to 0.453 59237, right? And then the milliliters to liter connection I gave you here. So there's 1,000 milliliters in 1 liter. And then we need liters to gallons. So I know there's 1 gallon in 3.7854 liters. So now I just multiply fractions, right? Just multiply straight across. So when doing so, this should give you right. So if we take 0.001 times 1 times 1,000 times 3.7854, so I get 3.7854 in the top, and this is in pounds, and then the bottom is in gallons, right? So to calculate the bottom, we're going to take 1 times 1 times this 0.45 number times 1 times 1. So really, I'm going to have this 0.45 number, right? 0.45359, so forth, right? And if I want to scale this to be in terms of 1 gallon, right, I can do so. I just need to take the 3.7854 divided by 0.45359, so 45359,237, right? And in doing so, you get approximately 8.35. So 8.35 pounds per gallon per 1 gallon. So this is in a unit rate, and that's more of how we would talk about something of this nature. All right. So in the last problem, it deals with a doctor ordering some medicine, and we want to know, is the recommended dosage within a safe range, right? So let's look at the facts of what we're given, right? So we ordered 2.3 grams of medicine, right? The patient taking it is 15 pounds 6 ounces, right? So 15 pounds 6 ounces is the weight of the patient. And this is taken every 8 hours. Right? So the recommended dosage, so this safe zone, if you will, right, is 75 milligrams per kilogram per day to 100 milligram per kilogram per day, right? So I want to know, is this dosage within this recommended dosage, right? Is it in the safe zone? So there's one of two ways you can go about it, right? So the first way is we can take our facts that are in gray and convert that information into the same units that we have here in the safe range, right? And in doing so, then we can just say, is my number in between 75 and 100? And if the answer is yes, then it's in the safe zone. And if it's not in the safe zone, then it's not within the recommended range, right? Another way you can do it is you can make the range fit your problem, right? So whatever makes sense for you, right? So what I'm going to do is convert this information, fit our zone, right? Fit the safe zone. So first of all, let's figure out how many milligrams of medicine that is being taken every day, right? So 2.3 grams equals blank milligrams, right? We need to figure this out. So 1 gram is equal to 1,000 milligrams, right? And you may have learned how to move in the decimal system by a silly saying. So it's King Henry died by drinking chocolate milk, right? So this is my base unit. So this would be like grams, and then over here this would be milligrams. This can just help you, you know, what to do, move in the decimal. So if I want to go to grams to milligrams, I go 1, 2, 3 spots to the right. So that's what you do with the decimal part, right? 1, 1, 2, 3, and you get 2,300, right? So if you've already done, you know, if you know how to do it this way, that's perfectly fine. If not, then you can just do a proportion, right? So 2.3 grams per you know, X milligrams equals 1 gram over 1,000 milligrams. So we would take 2.3 times 1,000, which will give me 2,300, right? Right. So notice it's milligrams per kilogram. So next, what you'd want to do is convert this into kilograms, right? Oh, and also one thing you want to notice is this is every 8 hours, right? So let's be clear on what I have right now. What we have right now is that our patient is taking 2,300 milligrams of medicine, right? So all I did was convert grams into milligrams. So they're taking 23 milligrams every 8 hours. So if I want to convert this into days, right? If I take 2,300 milligrams over 8 hours, and I want to convert this into days, right? Then there are 24 hours in one day, right? So if I multiply this, then my hours will cancel, and I'll get this in terms of milligrams per day, right? Or in other words, think about it this way: if you take a medicine every 8 hours, that's 3 times, right, in that day that you're taking it. So you're taking 2,300 milligrams, you know, at, let's say, at midnight, and then at 8 a.m., and then the next time would be what, 4 p.m., and then you would be back at midnight, right? So that would start the new day. So you're taking it 3 times in one day, right? That's the same thing that this will do, right? Because 24 divided by 8 is 3. So if we take 2,300, multiply it by 3, right? You get 6,900. Right, so this would be milligrams per day. Right? So if we want to take 6,900 milligrams per day, and notice the unit that we're missing is kilograms, right? So kilograms would be the patient's weight. So what I'd want to do is convert 15 pounds. So let me go down. So I'd want to convert 15 pounds and 6 ounces into blank kilograms, right? So if we look up at the chart above, right? So if you look at the top of your worksheet, we want to look for a connection between kilograms and pounds, right, under the weight. So we do have a connection between kilograms and pounds, right? So if I come up to the chart here, I'll highlight this in blue. We have this connection, right? So I want to save this connection in order to convert. So in order to do this, I need to have everything in terms of pounds, right? So let's say well, Tyler, I don't know how many ounces are in pounds, right? So if you don't know how many ounces are in pounds, you could simply just Google it, right? So let's do number of ounces in a pound. So there's 16, right? So that's a fact that we need to know, right? So there are 16 ounces in 1 pound, right? So in other words, 15 pounds and 6 ounces is equal to 15 plus 6 out of 16, right? Because there's 6 ounces, and to get 1 pound we have 16. So 15 plus 6 out of 16 pounds, right? So if we take 6 divided by 16, we get 0.375. So this tells me there are 15.375. So just taking this, turning it into a decimal pounds, right? So this just makes it easier for our calculation. So the new question becomes 15.37 pounds equals how many kilograms, right? So I can multiply this, do a unit, multiply this by a unit fraction. So I'm going to put pounds on the bottom and kilograms on the top. So that way these cancel out, right? And I'm left with kilograms. So the fact that we know is 1 kilogram is 2.20462262, right? Pounds. So if I take 15.375 and divide it by that 2.2 value from the table above, we end up getting that this is approximately equal to 6.973. I'll do 98, right? So I'll go to 5 decimal places, right, to help keep this accurate, right? So this would be kilograms. And you want to be as accurate as possible here, right? In fact, what I would do is you can actually just store this value in your calculator, right? So let me show you how you can do this. Right? So what I did in my calculator is I took the 15.375 divided by 2.2. See, it's 0.462262, right? So if we do that, we get this value. So this is probably a rounded value, right? And if you don't want to type this all in, what you can do is most scientific calculators, or if you have a graphing calculator like here I'm showing, you'll see some kind of storing feature. So what I can do is I can hit this, and then if I hit alpha and then A, I'm storing that answer as A, right? So in other words, I'm treating it like a variable. So every time I use A in my calculator, I'm going to bring up that value, right? So let me just make a note of this, that I stored this as A. So this is A, right, in my calculator, right? So if we come back up to here, right, just so make sure we're not losing track of what we're trying to do, right? So remember, I'm trying to get units of milligrams per kilogram per day, right? So I do have 6,900 milligrams per day, and then what else I know is this 6.9 value of kilograms. That's how much my patient weighs, right, which I stored as A, right? So what I need to do next is take 6,900 milligrams per day and divide it by 6. Oops. We'll just say 974 kilograms, right? So what would happen is when I divide, right, if I take milligrams per day and then divide it by kilograms, right? This is the same thing as milligrams per day times 1 over a kilogram, right? So this would be end up being milligrams per kilogram per day, right? So if I come back over to my calculator, right, to be as accurate as possible, we can take 6900 and then divide it by alpha A, right, because I stored that as A, and I get this value, right, 989.3916, right? So then the question becomes, is this within our range, right? So we can see. So if I come up here, this is my safe zone. So is 989 within this range? And the answer is no, right? That's much too high, right? 989 doesn't even come close to fitting in the range. So there's a big problem, right? The doctor ordered too much. All right, well, that's all I have for this worksheet. This exercise is harder to do. So you want to make sure that you're breaking this up and making sense of this as you go along, right?